All right, so in this example, we're trying to find the derivative of the function 3x to the fifth plus 5x squared minus 2x. And we're going to do this using the power rule along with the linearity properties of the derivative. That is, taking derivatives one term at a time. And as to recall, to use the power rule, you're going to take functions of the form x to the n up here in the right-hand corner. You're going to move this n down in front of your x, subtract 1 from the exponent, and that's what gives you what this arrow points to. And we're going to do this for every single term, that is all the things that are being added together. All right? So with this in mind, taking a look at our first term here, we're going to take our 5, move it down in front. So that becomes 15 when you multiply the 3 into 5, times x, and then you have to subtract 1 from the exponent. So 5 minus 1 is 4. So you have a 4 in the exponent. Okay, so that's the derivative of the first term. Try doing the second term yourself here. Take the 2, bring it down in front, multiply it by that 5, so that gives you 10 x to the first power, because you're subtracting 1 from the exponent. But you don't need to write that first power in the exponent, because x to the first power is just x. So you can delete that. Doesn't need to be there. All right, then the last term. So when you have a constant times x, all you need to do is get rid of that x. Just make it vanish, because that's just the thing that's underlined right there is a line of slope minus 2. So the slope of minus 2x is just going to be minus 2. That's one way of thinking about it. So the x goes away, in other words. Okay, and that's your derivative. That's how you do this using the power rule. Not terribly complicated. You just got to keep in mind how you handle especially the last term, then that minus 2x. The x goes away, leaving you just the constant in front of that x. All right.